Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good evening. Um, First of all, thank you for being patient. I've stopped accepting students who are requesting to join our session because it's now basically 10 minutes past the allocated or the supposed to start our session at 8:15, quarter past 8. Okay, for those who are being here early or on time, so again, thank you. For today's session, hopefully will be, I cannot promise it's going to be short, but hopefully this briefing will provide some answers or give some information, useful information before we begin our semester. Okay, so if you got any questions regarding the course or the planning for the semester for CFD, so please use this session to ask questions. Okay, right. All right. The course coordinator for this course will be myself. So I will be the only one teaching. MMJ, not ENT anymore. So it's MMJ 43303. So hopefully you are in the right course. So I hope you all still remember me because I think I recognize some of the names in the list of course registration. I've taught you guys before. So that's, I think, is a good thing because you know my style of teaching. Hopefully we'll get along well this semester. Okay, so for this course, I'll be getting help from Mr. Asro, teaching engineer. I think, again, all of you are quite familiar with him, as well as our lab technician, Mr. Amri. This will be, I think, quite an important person for you guys this semester for the lab, especially for the two labs that we planned to conduct for this semester. So I will go into details about the lab soon, but at least you can get his information. So I've already put down his email and telephone number over there. So if you need to use the lab outside of the allocated time in the timetable, so he's the person that you need to or you should be contacting. Okay. All right. So before we begin into detail, again, I'm just sharing the memo that was given by the PR to all students of mechanical engineering program regarding the plan for PNP or for teaching and learning for this semester. As you all understand, we are transitioning from the pandemic into endemic phase, and the faculty, the program has decided that we are also going to start enforcing the face-to-face meeting for the lab and also for the tutorial as well as for the lecture. Okay, however, we still have 1 hour slot, which we are going to look in a bit, 1 hour slot at night, which I think, obviously for me, I think I'm going to go for the online meeting or synchronous session for the 1 hour slot. But the rest for the 2 hour lectures allocated for us, it will be face to face. And I think, as you can see over here, for 2, 3, or 4 credits courses, you will have face to face meeting starting from this week. Okay. So again, for today, I apologize for not being able to join or see you at class face to face because I've got another commitment until Wednesday. So hopefully, inshallah, I'll see you guys next week for physical classes or physical lectures. Okay? So if you've got any issues regarding this, for example, if you got visa issue or any health problems that needs basically some time for quarantine, anything like that, please let your RPS know and then just CC me the email. Okay, because I think I've got 1 or 2 students already contacted me regarding health issues that I think it's important for me to know, but I think it's more important for your RPS to be kept in the loop. Okay. All right. So so first thing first, let's look at the timetable. All right. So this is the general academic session for this semester, semester 2. I believe you all are aware with this, so I'm just going to share this briefly. So we have, again, roughly about 14 weeks of teaching and learning. The midterm break which I'm going to go into detail in a bit. But as you can see over there on the screen here, our midterm break normally usually is between week 7 or week 8, but now has been moved quite early. I think week 6 right now, due to the Eid Mubarak or Idul Fitri. Okay, so that's, I think, something that is quite a major change from previous semester, because usually we have week 7 or week 8 or even week 9 for the midterm break. Yeah, I hope you are aware of that, and also, of course, the holidays along the semesters. Yeah. Okay, so this is the schedules from the faculty or from the program. I think it has not been changed since it was last published. So I hope you guys can agree on that. If you got any issues with this timetable, please let your RPX know. But if you are in the right semester, in the right cohort, you shouldn't be having any clash or any issues with this course or other courses. Okay. So again, this is the timetable that we are given. Okay, and of course, it's quite important because for semesters two, there will be the month of Ramadan at the start of the semester. So we will begin the month of Ramadan this Sunday. So that means next time we meet, inshallah, next Monday, we'll already be in the month of Ramadan. So luckily, if you look at our schedule, I hope this is the right schedule that I'm showing right now. So if you got any issues or something that's not right, please let me know. So the good thing about our schedule is that for our lecture, we'll be meeting on Monday from 2:30 until 4:30 in the evening. So there shouldn't be any issues with if you want to go back earlier to break your fast or anything, okay? Because our class is from 2:30 until 4:30. But I was informed that you have another class after our class, which is, I think, IR Shahabuddin, which starts at 5 o'clock until 7 o'clock. So I think that's something that you need to discuss with your lecturer. Okay, and then we have our 1 hour slot, asynchronous. So I put here async because I don't think myself or you, for example, students would want to have a face-to-face or online class at 8 p.m. In the evening. So for this lecture at night from 8 until 9, so I already put some notes over here, so it'll be synchronous. So it can be some lectures that I will share, pre-recorded lectures, or some asynchronous materials that I will share from time to time. Okay, so we'll have a face-to-face meeting for the 2-hour lectures, and 1 hour lecture at night that will be asynchronous. Okay, as for the lab, so we have 3 labs over here, 3 slots. So we have year 4, group 4, year 4, group 3 on Friday, as well as on Friday again, year 4, group 1 and group 2. Okay, so we have 3 groups, and hopefully there shouldn't be any issues. And more importantly, soon I will upload a Google Sheet on the Google Classroom so that students can fill up the corresponding labs that they are assigned to, because we need to make sure that the students go to the designated slot. Okay, because we have a limited amount of computers at our Mechanical Design 1. So that means I have to make sure that students only go to their respective slots. So basically, you cannot, for example, or I say, maybe you say, okay, I want to change my slot because on Friday it's too early for me to wake up for group 3. So I want to go on Monday, or maybe I want to go to the next session. So you cannot do that. Okay. So I think the details about the lab I'll explain once we meet next week, inshallah, so that there are, I think, quite few information that I want to share with you about the lab. Okay. So, but this is the schedule that we have so far. All right. Okay. If you got any questions, please let me know. All right. Okay. So, my first question, or something that to discuss, I would like to propose that we move the time for the lab on Friday from 8:30 from 8 o'clock, lab on Friday, lab year 4, group 3, okay, from 8. So we move to 8:30 and we'll finish at 10:30. So similarly, I propose to move the group 1 and group 2 slot from 10 o'clock to 12:30. It's not AM, PM over here. Okay, so can I get some feedback right now? Yeah, are you guys okay with this proposal? Because I think 8 o'clock might be too early for some students, and even the lab, basically we want to give some time for our technician to come to the lab and then to switch on all the computers, everything. So is it okay for everyone if we for the slot on Friday we move half an hour beyond the allocated time? Is everyone okay? Can I get some response from student? Anyone? Okay, yeah. All right. So I can't hear too many confirmation, but I will again put this in the Google Classroom for attention, for everyone's attention, as well as I'll confirm again next week. But this is the proposal that I would like to make to our students, so that you can have time to wake up a bit late on Friday. Okay. All right. Okay. So about our course. Okay, this is the teaching plan, which I think is quite important for all students to know and to understand. Okay, so I think the details here is quite self-explanatory. So this course code is MMJ43303. So hopefully you registered to the right course. Okay, I got. Okay, and then this is a 3-credit course. And we offered this course only for mechanical engineering program students. So in this course, I'll be helped again. I will be getting help from our teaching engineer, Mr. Asrul. And so far, we have about 62 students who registered for this course out of 70 estimated. So which is not too bad. Okay, so I'll proceed to the next one. Okay, so just take a few seconds to understand or to get some information regarding the course or the synopsis of this course, what this course is about. Just take a few seconds. Okay, so I already highlighted the important part of the synopsis. So basically, this course offers an in-depth introductory foundational and technical knowledge in solving thermofluids problem via CFD, computational printed. So in particular, students will have hands-on experience in using computational fluid dynamics to solve engineering problems. So basically, some of the topics that will be covered are underlined over here. We have governing equations, discretization methods, numerical methods, turbulence modeling, quality and independence tests, and so on and so forth. Okay, so the underlined parts here, these are some of the topics that will be covered in this course. Okay, all right. So again, as usual, before we start at the start of the semester, we'll have to understand or we'll look at the course outcome, what is expected of the students at the end of the semester. So we have in total 4 course outcome. Okay, let's call it CO. For CO1, ability to analyze and apply basic fluid dynamics related partial differential equations. Okay, with the level of complexity C4. So I hope you understand by now what is C4, C5, and C6. So basically C4 is up to the level of applications. How do you understand or how do you apply what you understand into solving problem? For CO3 is about ability to analyze and apply basic discretization schemes for fluid dynamics related partial differential equations. Again, the level of complexity is C4. And for the third CO, ability to assess and solve fluid dynamics related problems by using appropriate numerical procedures. This is up until C6, meaning that it involves a design problem or complex problems. And finally, for CO4, ability to solve fluid dynamics related problems by using computational tools. And this is P4, basically meaning that this is psychomotor, this is lab. Okay, so this is the assessment for the lab. Okay, so basically what I can summarize is the first CO basically deals on the derivation of the runs or the Navier-Stokes equation. I'll explain later on when we start with the introduction to CFD. You might know how to use CFD software like NSYS, for example, but do you really understand what is happening behind the software? So what is the calculation involved? Okay? So in the first part, CO1, we will look into the equations involved on how we get to the Navier-Stokes equation. So Navier-Stokes equations basically equations that is being used to solve all kind of fluid problems. Okay, so that's about CO1. CO2 is about discretization method. So basically, when you have a problem in CFD or in numerical modeling, and not just CFD, basically CFD, or if you have taken the numerical modeling course with Dr. Sani, when you have an object, basically numerical modeling is a method that you slice the object into a smaller pieces, and that pieces is called elements. So basically, there are a few methods to do that, basically, slicing or meshing, we call it. So that method is basically discretization. So we have a few methods that we are going to look, and at least we are going to cover at least one method, and that's about CO2. Okay, basically how we can use a certain method for the meshing process. And CO3 and CO4, actually, they are quite related. Basically, CO3 is about assessment on your understanding on the CFD procedure, basically. About boundary condition, it's about meshing procedures, about convergence, something that you will be doing in the lab and basically will be translated into a problem. Okay, so that's basically the summary about our CO. Okay, all right. So for the lab, there will be 2 labs tentatively. There will be 2 labs planned for this course. Again, the title over here, this is just a rough title. So basically, lab 1 basically is about analysis of fluid flow passing through an object. So basically, you have one object in the domain using CFD software, which is NSYS. Lab 2 is analysis of fluid flow passing through 2 or more objects. So the difference between the first lab and the second lab is the number of objects. The first lab will involve just one object, and the second one will involve 2 or more objects. Please note that our lab will be open-ended. Okay, so what that means is basically there will be no instruction given. For example, okay, click this and then insert this value to do convergent analysis. No. Okay, so I'll give you a set of problem, and students basically need to figure out how to solve that problem. So for example, for lab 1, because I'll explain in detail once we get closer. Could you please mute your microphone? Someone, siapa yang ni? Please mute your microphone. Okay, so for example, for the first lab, I'll give you a technical paper that have the domain. Could everyone please make sure their mics are muted, please? Okay, so for example, for the first lab, I'll give you a technical paper, basically that has the details about the domain that they use. And basically, students just need to follow the steps from the paper to produce results that is quite similar to the paper. And then what you need to do is basically, you need to do the analysis, basically, between your results and the results from the paper. Okay. And for the second one, basically, is more open-ended. You'll have to choose something. Okay, of course, I'll explain in detail as we get closer to the lab. But you need to choose something that is related to the SDG, which I'll explain in a bit what is SDG. But hopefully by now, in the 4th year, you are familiar with SDG, Sustainable Development Goals. So you have to relate your second lab, your problems that you are choosing with SDG, how your problems that you're trying to solve for second lab relates or can contribute to the SDG. Okay, all right. Okay, so the list of textbooks are as follows. Just a few moments ago, before we start our session, I've shared in Google Classroom several of PDF documents that you can use, okay, for this course. Again, you can use any other sources that you think can help you understand. But, excuse me, the main textbooks that we'll be using basically is not just one. Basically is a combination of several textbooks that I use to extract the materials for our syllabus. Okay, so these are the textbooks that I recommend for you to find. Okay, but I've also shared a few textbooks, a few documents in the Google Classroom. So please have a look later. Okay. Oops, sorry. Okay, I hope you can still see my slide. Okay. All right, so this is the teaching plan. Again, this is tentative teaching plan for our course. All right, so I'll just go quickly on the topics that we're going to cover. So we'll start with the introduction to CFD, and then introduction to CFD procedures and tools. So basically, this is a CO3. So instead of starting with CO1, we'll start with CO3. So the reason why, because previously I've got input from students saying that they wanted some helps, especially those who are doing CFD modeling for their FYP. So by moving this intro to CFD procedures earlier in the semester, hopefully student can ask questions during the lab or during the lectures to help them understand more or better about the procedures that they are doing for their FYP. Okay, for those who are doing FYP in CFD modeling. And if you note over here, our lab will begin tentatively on week 3. And if you look over here, we have the first lab, the first lab basically takes 4 hours, okay, on week 3 and also on week 4. So 2 hours or for 2 weeks, so 4 hours total. Okay, so we have 4 hours for the first lab and 4 hours for the second lab. So please note, so this will be translated into the percentage of the assessment, which I'm going to share soon. Okay, and so again, midterm break on week 6, and I put the corresponding date over here on the right side for holidays that we will encounter throughout the semester. And then week 7, we'll continue with governing questions of fluid dynamics. So basically, the good thing about this course is some of it we have covered in other courses. So for example, week 7, we've covered this course partially in Fluid 1 and Fluid 2. It's about the governing questions of fluid dynamics. So if you focus or if you understand well Fluid 1 and Fluid 2, it should help a lot in this because we will start from the beginning of the derivation until the end. So that's why it's important for students to always remember what they have learned before. Okay, and the corresponding, if you look over here, we'll have our test plan on week 9, as well as our assessment assignment 1, 2. Okay, if you look over here, week 7, Wesak Day, it falls on 15th of May, which is Sunday. So if I'm not mistaken, holidays that falls on Sunday will be pushed into Monday. So that means if that happens, we'll have to think about replacement class on week 8. Okay, so I highlighted in blue over here. Okay, but let's focus on what we have on hand. So we'll get there when we get there. Okay, so when we continue here, we'll have our second lab on week 10 and also week 11. Again, 4 hours lab. Okay, 2 hours each week. And again, we have another birthday, Agnes' birthday holiday, which is on the 6th of June. Again, we have to think about replacement class for this one. Then we'll proceed with finite volume method and turbulence modeling. Or it's not turbulence modeling, introduction to turbulence. Okay. So if you got any questions, please let me know. All right, so I think this is quite important for you to understand the plan assessment throughout for this semester. Okay, so the 4COs were covered before, and the components that will be assessed. So, for example, for CO1, again, this is tentative. It might change throughout during the semester, but this is what we have, what I have so far that is planned for you guys. So we'll have quiz 1, assignment 1, and test 1, question 1 for CO1, and final exam question 1. Okay, so that's for CO1, which is the derivation or the partial differential equations of the fluid dynamics equation. Then for CO2, we'll have quiz 2, assignment 2, and final exam question 2. And we have next CO3, test question 2, final exam question 3 and question 4. And finally, we have the lab, CO4, lab reports. If you look over here on the right side, continuous assessment. So just 1 second, I think you can see my mouse. Pointer options, let's see, point. Okay, so if you look over here, the percentage for the lab is 16. Okay, so over here, all right. So we have final exam 60%. I think that's the standard for almost all courses, conventional grade. Okay, for the coursework, we got assignment 6%, quizzes 8%. So we have 2 assignments, 2 quizzes. So for assignment 3% each, quizzes 4% each. And then we have lab reports 16% in total. That's for 2 lab reports. So I would like to emphasize over here now over here so that everyone understand. Lab plays a very important assessment for this course. Okay, so please make sure to understand that the lab that will be covered this semester is not like normal or other courses in the lab that you can just copy and paste from your friends, or you can just basically do it last minute and submit and expect to get some grades. No, you have to put some efforts. That's why is one lab takes about 2 weeks. Okay, that's estimated time for you to finish, assuming that you can finish everything within 2 hours each week. But the 60% here, hopefully, you will understand the importance of this assessment. Okay, and finally, the test. We only have 1 test, which is 10%. So we have 2 questions that will be the test. So 5% each for over here. If you look over here for CO1 and for CO3. Okay. All right. So hopefully you get some idea on the assessment components. So again, I would like to emphasize over here, our labs will be open-ended. Okay, so please make sure you understand it's important to do well in the lab. Okay, but before we proceed, again, I know you're in the 4th year, but I just want to recap. It doesn't matter how good your coursework grade are, because at the end, you need to pass your final examination. Okay, so 60% over here. Okay, so if we convert 60% to 100, you need to get your final examination 40% or more out of 100 in order for you to pass any course. Okay, not just for CFD, for all the courses. Some students might forget this, but this is the reality. Okay, so please remember, doesn't matter how good your carry mark is, which is your coursework. If you don't perform well in the final, okay, by the way, the final will be face-to-face, so no excuses for this semester. It will be face-to-face. So if you cannot get 40% out of 100 for the final, you will fail the course. That's the reality. So it's as simple as that. Okay, so you need to pass the final in order for you to pass the course. Okay, so hopefully I make myself clear over here. Then, okay, so other information, SDE will play quite an important role in most of the subjects for the past few semesters. So for our course, we will cover mostly SDG 7, which is affordable and clean energy. and also SDG 13, which is climate action. So if you don't understand what SDG is, hopefully after this briefing section, go have a look. Just Google what is SDG, because we will cover this anyway in our first lecture next week, inshallah, in the introduction to CFD. Okay, so we'll also cover this, okay, as I mentioned just now, in our lab. Okay, so basically you need to do something that is related to SDG or contribute to SDG for your lab. All right, let this just. Okay, I got questions. Question today? Question from students? No. Okay. I can't see any. Okay, anyone has any questions? Okay? Check. Also, I got some checks. Okay. All right. Okay. So let's proceed. Let's not take any break. So because I think I think everyone wants to finish this as soon as possible, including myself. So let's speed up a bit. Okay. So I explained just now why our CO's arrangement is not the same as syllabus. Why we start with CO3 because my aim is to help students who are doing CFD. Is it an advantage for students doing their FYP in CFD field? In a way, yes. Okay, but what we are doing, what we are covering in CFD course, this course, basically not just an application. The application is just CO3 or CO4. We have CO1 and CO2, which is the derivation, the understanding what is behind the CFD software. So those who are doing FYP in CFD, I think that's an advantage in terms of the lab because they have some understanding already in terms of ANSYS Fluent. But for those who are not doing CFD related work for FYP, for example, you're doing experimental work, not to worry because I will share with you, I already shared in Google Classroom basically, my Facebook channel. Basically, if you go to my Facebook channel, sorry, not Facebook channel, my YouTube channel. Okay, so if you go to my YouTube channel, you'll notice that there is one playlist on FYP works, basically that has been done by my previous students. So if you go to the videos, I think it will be very beneficial for students to get started with CFD modeling. So even though you are still a novice, you never used CFD software before, but by watching that video, it definitely will help you with your labs. Okay, definitely with your lab. Okay, all right. Okay, so let's proceed. Syllabus teaching plan. Okay, so this is the syllabus of teaching plan that I try to summarize in terms of figure. Okay, so what we will cover, the first one is basically how to use CFD tools. In this case is the ANSYS. Okay, so basically this covers CO3, and pretty much this is what we are going to do for our labs. Okay, we have a domain, we have an object for lab 1 and several objects for lab 2, and then we are going to see basically what happens when the flow passes the objects. Okay, so that's for CO3 basically. Okay, how to use computational tools, which is ANSYS. Of course, we are going to cover the theory as well, not just how to use the software. Okay, next, this is the derivation of the Navier-Stokes. We are going to look at basically how to analyze the particles in the flow. Okay, so instead of looking at the flow as a whole, we are going to focus on one small element in the flow. So these are basically some of what you will be learning in CO1. Okay, basically we're going to look at the rate of mass flow, the rate of momentum, and how we derive the PDE to get the Rank's equations. Okay, and next, the second CO. Basically, we are going to look at discretization method. So one method that will be focusing on is called the finite difference method, FDM. And if we have time at the end of the semester, we'll cover finite volume methods as well, FVM. Okay, so I hope these 4 figures can give some inkling or summarize what we'll be doing this semester. So I got questions from Firdaus. Okay, for the lab, do we just use the software in the lab or we have to install in the laptop? Okay, I'm going to get to that in a bit, Firdaus. So let's KIV for now, but I'll answer that in a bit. Okay, so thank you, Firdaus, for the question. Okay, all right. So in essence, basically, apart from the figures, CFD is the basically culmination from Fleet 1 and Fleet 2. So if you look at the syllabus, this is from Fleet 1 and Fleet 2. You already covered some of the materials, basically the derivation of the runs. Maybe not in details, okay, but you have covered that. So we are going to use that basically and look into more details. Okay. All right. So the learning outcomes, basically, what is expected of students, hopefully at the end of this course, are as follows. How to apply discretization method, MDM, FVM, choose an adequate computational method to solve fluid mechanics problem, evaluate the quality of the numerical solution. This is quite important because I think most of the students, when they're given a tool, okay, in this case, NCS Fluent, you can just put some values and you will definitely get some output. Okay, the question is, how do you validate or how do you know that the output that you have is right or wrong? So that's what we're going to look in this course, okay, to evaluate the quality of numerical solutions. Okay, basically to prevent short sendiri lah. In bahasa, we call it short sendiri lah. Okay, all right. And then number 4, to recommend the use of a computational method or a theoretical approach for fluid mechanics problem. Understand scientific publication in the area of CFD. So because this is also for point number 5, that's part of the lab. Yeah. Okay, so to understand scientific publication. Okay, so some of the course materials listed here. So apart from the one that I've shown before, these are some of the materials that you can use to help you understand better for this course. But the main textbook, okay, again, as I said before, there will be no one textbook that covers everything. But if I can suggest one textbook for you to look at or to make a reference to, it will be the first one by J. Anderson, Computational Fluid Dynamics, the Basic with Application. This is a very, very old textbook. I think this was published, I think maybe 1970 something. But this is a very, very good book that basically shows you the detailed derivation of the runs equations, which is very, very important for our course. Okay, so this is one textbook that I can recommend, which I already shared in Google Classroom as one of the document. Okay, so other books or sources that you can use, of course, it's not the old, your fluid mechanics book, textbook. I believe you have fluid mechanics books, which I think this should help cover the first CO as well, derivation of the trans equations. Okay, apart from that, we are not just going to look at the derivation. To be honest, the CFD is such an interesting and challenging field, I would say. And there's so much to cover this semester. So if you would like to know more before we start our course next week, our meeting next week before we meet, this is the old one, but I've uploaded similar links to our Google Classroom just before our class tonight. So please have a look. Okay, I think you'll find this link very, very useful for your work or for your understanding for this course. Okay. Okay, this I'll just go briefly. By now in 4th year, if you have been in my class before, you know how much I value academic honesty. So something to avoid is plagiarism. I have to emphasize this because every semester we have students who copy and paste some assessments from lab reports and also their assignments. Okay, so please do not be that student. Okay. I understand, I hope you understand by now what is plagiarism. Okay, you cannot just copy and paste something, take something that is not yours and then claim to be yours. Okay, so as simple as that. By now, hopefully again, you understand that doing group work is okay, but the submission must be individually. So please understand that, and you can go to this link, okay, to understand more about UNIMAP's policy on the plagiarism. Okay, um, again, this is in Bahasa. Unfortunately, I can't find in English. This is from the academic book for postgrad, but it should be the same for undergraduate. You cannot. So basically, what I can summarize is, do not submit something that is not yours. If you didn't do it, if you didn't write it, do not share or do not submit as your submission. Okay, all right. So again, this is some of the problems that we have been facing for every semesters basically. Someone's use seniors or past year answer scheme to report for assignment, for your lab report, and during the online course for the past 2 years, we have checked that has been the main source of help for students. So again, avoid all this, please. Okay. All right. So I'm just going to skip this. Okay. About the attendance. Okay. About the attendance, again, if you have been to my class, you know that I'm quite flexible with attendance. If you got any problems, please let me know. But unfortunately, the university requires basically for the attendance to be recorded in a proper manner of official attendance. So do what you must, but as long as you fill up the attendance, I'm a happy lecturer. Okay, so you know my point of view. If you want to study, you come to the class, you ask questions. If you don't want to study, then that's up to you. Okay, but from my point of view, as long as students submit the attendance, fill up the attendance quiz, then you're good. Okay, all right. So if you've got any issues, obviously, if you've got any emergency, please let your RPS know, and of course the PR, and please CC your lecturers. Okay. Okay, I have covered this. You need to pass the course by passing the final exam, which is above 40% out of 100. Okay, so I've covered this. And please, I think I've shared this link already in Google Classroom. You can go to my channel on YouTube. Just look at previous work done by my students on basically ancestry, on using ancestry basically. Okay. All right, so check this. We covered teaching plan, teaching material, book medium. Okay, Google Classroom, I'll cover it in a bit about Google Classroom. Okay, please, it's very, very important to join Google Classroom using UNIMAP Gmail account only. Okay, otherwise I'll kick you out because all the submissions, most of the submissions, assignment, as well as the quiz will be conducted through Google Classroom. So I need your official Gmail account from UNIMAP to proceed. Okay, we covered about the schedule. Okay, list of students not relevant. Okay, we covered these two. Okay, attendance detail. Okay, not quite. Okay, I haven't covered about the quiz. About the attendance. But I think I have a slide dedicated for attendance in a bit, so just be patient. So I covered this in a bit. Lab session. Okay, so lab session, I think Firdaus already asked. I'll cover again the lab in a bit, but it will be individual submission, not group submission. So we covered about the assessment component as well, the percentage. So especially the lab. Okay. Okay. The medium of communication will be mainly Google Classroom. So far, I have 59 students enrolled to the Google Classroom up until I think 7 o'clock or maybe 6 o'clock today. In the system, we have 62 by this evening, I check. So we have a few students who are yet to join our Google Classroom. Please do so as soon as possible because I've already started sharing materials on the platform. So, and I expect this number to increase because we have several students who are doing manual registration. So, but hopefully the maximum will be, I think, 65 or maybe 70 students. Okay. All right, so we discussed about the component. Okay, I think now I'll try to answer Frida's question. For the lab, do we just use the software in the lab or we have to install in the laptop? Okay. Okay. we have 3 lab sessions. Okay, so to answer Frido's question, so at Mechanical Design Lab 1, so we have 22 computers, PC, that have basically ANSYS software on that. Okay? Okay. However, okay, I would like to emphasize over here, the version installed on the PC at lab is the old version, which is 2014. Okay. I personally would encourage students to bring your own laptop so that you can use or you can create or you can do your lab on your laptop and then continue straight at home. Because if you do your work on the lab, on the computers at lab, so what will happen is when you try to save your file on the old version, and then you move it to your own laptop, which basically you can use academic license, which is free, by the way, there will be problems because the new version cannot recognize the old version. That's a problem, and vice versa. Or maybe the new one can recognize the old one, but there will be some compatibility issues. That happens previously. So to answer Frido's questions, the computer lab has ANSYS software installed, but I personally would recommend you to bring your own laptop that has been installed with ANSYS academic license, which is free to download and to install. Okay. Academic license, there is some limitation. Okay. However, the problems that we're going to do doesn't use much nodes or element sizes. Okay, there's a limitation in terms of I think 500,000 nodes or something on academic license. So the one that we are doing for the lab doesn't require much meshing or nodes elements. Okay, so hopefully that answers Frido's question. Okay, all right. Laptop PC is a must. Okay, again, this is during PKP, so might not relevant right now. As I said, we have access. You have access to the lab, which has everything installed, but there's an old version. So again, I think I recommend you to bring your own laptop PC if you can install and run the software. The recommendation for ANSYS are as follows: at least 4 cores, Windows 64, 4 gigabyte or higher, and RAM, of course. Okay. So I think I would recommend for you to download and run the software before the lab so that you know whether your computer is able to run the software. Okay, I promise you the problems that we're going to run shouldn't take too much, or the domain. I mean, the domain is not too big. I'll try to upload the technical paper for you to have a look as soon as possible. Okay. All right. So okay, again, this is basically quite relevant right now. Although this was my slides during the last PKP 1 year ago. There's ENT 441 CFD. So I think again you can use your PC if possible. Okay. How to find the course materials? Please go to the Google Classroom. Everything will be posted over there. Okay. How to do well in this course? Okay. I think this is basics lah. Just a few things, few pointers lah for you to pay attention to. Okay. How to not to use well. Okay. You all know this, so don't copy and paste. And if you try something doesn't work, try something else or try using alternative methods. Okay, lab planning. Okay, this is a bit detailed explanation. Okay, the first lab, basically you have an object. Okay, let's say you have a domain. Okay, this is just a rough line. This is a quick explanation. Let's say you have an object over here. Then you simulate a flow, and then you have to validate. Okay, because the first lab, the purpose is I want to teach students to understand just by simulating something doesn't mean the final answer that you get, the output, the post-processing output is right. So once you simulate that, you'll have to basically make a slice or rig that extracting the data from a certain location and then you validate with the data published from the technical paper that will be shared. So the first one basically will be based on a paper. Okay. So again, that's why I say it's open-ended. So your answer will be different, totally different from your friends. So it's impossible to get the same answer. Okay. So for the second one, you instead of just one object, now we have to simulate two or more objects. But again, over here, you have to relate with SDG. Okay, how your problem basically help to contribute or solve SDG issues. Okay. So again, both labs are open-ended, but open-ended doesn't mean it's difficult. It means that basically I accept all kind of answers as long as you address the issues that I wanted. Okay. So as for the pre-lab, there will be several materials that you need to cover, especially you need to understand the technical paper, the dimension, what to be designed, or the domain, how big the domain should be, where to extract. So those kind of things. So more importantly, the paper, you need to understand what the paper is about. And for the submission, again, I'll explain in detail as we get closer to the first step. Okay. Right. Okay. All right. I think this is something that I would like to highlight again. I guarantee something. I guarantee our test question will be exactly like the tutorial question. Okay, please. This mindset is very, very wrong. Okay. Tutorial by right shouldn't. I or lecturers shouldn't be giving any questions during tutorial by right, because the tutorial should be used for students to ask questions, not for the lecturers to give questions. Because when we give questions, then the students usually they misinterpret and then they say, "Oh, the lecturers give this type of question, so it must be the same the same question that will come out in the final." So that's a very wrong attitude lah. So that's why for our tutorial, I expect questions from students, okay? Not the other way around. Okay, all right. So because usually this is what will happen, okay? All right. Okay. Okay, I've got another question from Shahira. Shahira, laptop kena berapa RAM untuk, okay. Kalau, yeah, thank you, Amin, for answering that. Kalau if you just search requirement for NC's academic, it says we need 4 gig. Okay, but usually, from my experience, 4 GB of RAM is the minimum. You can run, but that means you cannot run anything else, or you cannot use any other software while you're using NC's. And for a simple simulation, you might survive, but if we go after a certain domain size, you will have difficulties because the resources they tak cukup, not enough. So 4 gig Shahira is the minimum recommended. Okay, you can, I think from experience, some students, my students, they manage to run with 4 gig, but it takes hours maybe days to finish. But again, I cannot say for sure right now your computer with 4 GB cannot run. No, just give it a try. Just install it and then try to run a few problems and see how it goes. Okay. Alternatively, you can use the PC and at the lab. Okay. All right. Thank you. Okay. Attendance. Yeah. All right. For our attendance, if you check our Google Classroom, I have already posted our first attendance. Let's not call it quiz lah. For the attendance, basically, I will post during the session. For example, when we have a 2-hour meeting class at 2:30 until 4:30, I will post it in between the session, and it's not listed here, but basically I will give 1 hour leeway, basically extra time. So we'll end class after 4:30. And I understand that you have another class at 5 o'clock. I actually would it. So I give you basically until 5:30 to submit the attendance for the 2-hour lecture. Yeah, for our 2 hours lectures on Monday. Okay. And then we have another hour asynchronous session at 8 o'clock at night on Monday, every Monday. So I understand that for example, during Ramadan, kita berbuka and then After you break your fast, you want to take a moment, solat, and then you want to go taraweh. So I understand all that. Even after Ramadan, uh, it's quite difficult. It's not difficult, but sometimes students at 8 o'clock they have another things that they do, even though it's slot allocated for study. So for the next session, so asynchronous session, I give until the next day at 12 o'clock for you to submit. So you have enough time basically at night, maybe early in the morning, you wake up early, 5 o'clock, 7 o'clock. After subuh, just watch the synchronous and answer the attendance quiz and submit by 12 o'clock on basically Monday, Tuesday, 12 o'clock at noon. Okay, so I hope that should be okay lah for everyone. Okay, worth noting. All right. Again, this is something that we'll cover in our class. So it's important to remember your previous courses lah, PDE integration rate, calculus, and of course for fluid courses. So we are going to cover, for example, the momentum, the vector. We'll cover before runs equations. We have Euler's equation, how we get Euler equations. But importantly, is your calculus lah, PDE and also integration. Okay, that's for the first two derivation. For the first two COs. So hopefully you are aware of this. So this is what we'll cover. Again, I think I've shared this before in the previous class. In the final, oh my God, please handwriting, even in for your submission of assignment quiz, please write something that is eligible, something that I can read so that I can give you marks, please. Okay, SDG, just quickly. I think by now you should understand what is SDG, but in case you forgot or you, for some reason, you haven't heard about SDG, SDG basically is an initiative by the United Nations, UN. They proposed this SDG, Sustainable Development Goals, in 2015. What is the purpose of it? Okay, basically, it's a universal call to end poverty, protect the planet, and ensure that all people enjoy peace and prosperity by 2030. Okay, again, sounds too good to be true, I know, but this is a good step or a step forward. Basically, upon the proposal, they start proposing this long before that, but in 2015, when this basically becomes official, there is no basically a strict, let's say, there's no strict guideline that's saying, okay, for example, okay, Malaysia, you need to cut your carbon emission by blah, blah, blah. No. Basically, what happens is all the countries in the world, Malaysia included, they propose what can they do, what can we do, Malaysia, what can we do, contribute to all these 17. So, for example, okay, poverty. How to end poverty? Is it honestly possible to end poverty by 2030? Okay, but we can develop or we can make a plan on how to reduce the poverty as we go along. Okay, so the goal is being set by the respective government, not by the UN itself. Okay, so it gives the leeway or it gives the freedom to the countries to contribute what we can. Okay, so basically, okay, I mentioned this about the two SDG that we are going to cover. 7, affordable clean energy, and 13, climate action. But, excuse me, in the lab, if you can find any problems that, for example, you want to address something about, for example, life on land, for some reason, you are interested in doing life on land. Of course, you need to find something that is relevant to CFD course. Like, for example, it's, I think, SDG number 5, gender equality. How are you supposed to simulate something about gender equality? So choose something that is relevant to our course, of course. Okay, so we will try to address this in introduction as well as in the lab. Okay, so I'll try to explain during the introduction so that you can understand and then you will decide yourself on what SDG to be used or to be addressed for your lab. Okay, okay. How about Malaysia? So I highly encourage you guys, go to this link and check some of the goals set by Malaysia to help achieve Malaysia's SDG ambition. Okay? If you look over here, and for example, and you compare with the one, for example, in UK, for example, in terms of climate change, it's like comparing apple and oranges. Like for example, in UK, they have renewable energy in terms of wind, solar power, and then offshore winds, and then tidal energy, wave energy. It's not something that we can compare like apple to apple. Okay, Malaysia, for example, in terms of renewable, they try to encourage or reduce the dependency on petroleum, try to encourage biomass, for example, something like that. But it's interesting to read this document because it shows that Malaysia, we have a plan. And basically the goal or the target is not something that can be achieved by present government, for example, for the next 5 years. No, it's something that is continuous. For example, maybe it's your turn for the next 15, 20 years. Okay, long after my time, maybe your children or your children's children. Okay, so it's not something that we can achieve. Okay, for the next 10 years, we'll definitely achieve something. No. Okay, so I think it's very, very interesting read. So please have a look if you have time. But again, if you want to do well for your lab, please read this document. Okay, your first task, okay, just, it's not task lah, basically just look at your Google Classroom and the additional materials that I posted. Just have a look, okay? On basically, it should help your understanding on CFD. Infographic, which is quite important for me because this basically your assignment, assignment 1 or was it assignment 2? Your submission should be in terms of infographic. Nowadays, as an engineer, you should be able to present your data concisely, but in an interesting way. So we no longer want like 3 or 4 pages full of sentences, paragraph to be presented to the audience. No. So try, even not just for CFD, for other courses as well, try to implement or to use infographics in your assessment. Okay. All right. Okay. All right. Okay. So these are some of the examples by previous students, not for CFD class. I think this is for another class. It's quite simple, just to summarize everything in terms of infographic. All right. I think that's the end of our briefing session. Before I let you go, I have 2 questions, just to get some feel from students. Will you go to menti.com and enter the code? Okay, so the first question, why are you taking this elective course? Because we have other courses as well for electives. I'm just curious, can just give some reasons? What are your reasons for taking this course? Can you go to Menti, please? Assignment, okay, Amin Ismail, assignment in group or individual? Everything, all the assessments in this course will be individual, okay? So there will be no group assessment, okay? First question, please. Why are you taking this elective course? Go to Menti and then please just give your answers. Honestly, yeah? Just give your honest answers. Okay, so I'll give you about 1 minute to go to Menti and fill up. And hopefully everyone is still awake. So let's wait for 1 minute before I share the result. Okay. Okay, let's see. Okay, how can I... Okay, so I want to share. Well, unfortunately, I got only 4 responses. I'm not sure what happens to the rest. Okay, let's share the results. Okay, so stop sharing. let's see, share second screen. Okay, okay, maybe not the screen. Yeah. Oops. Sorry. Right. We have to cross continue here. Right. I can't share it. Why? Just 1 second. Scott. Okay, so let's see the results. Okay, so we got 70 response out of how many students? How many participants? Out of 47. Okay, let's see. I want to try this course, okay? You want to try. I'm not really sure what you mean by try. This is not food. Useful for my future job? Yes. Nowadays, CFD, numerical modeling, lah. I'll say CFD as part of numerical modeling. It's a sort of the skills, huh? Related to FYP fields, yes. Challenge myself, okay, that's a good thing. Improve NC skills, okay, hopefully. CFD is the future, I agree. Specialize in CFD. Not maybe not specialized, but at least this should give you the introduction or the heads up lah about CFD. What other thing? The other elective. Oh, basically you have to choose 2 electives, so this is the other elective. Feel is the future. Relate. So basically the main comments or input from students basically about the future and main FYP lah, related to FYP, similar to my FYP. Genuinely interesting. How do you know it's interesting when you haven't we haven't started covering the course yet? Master opportunities, okay, that's good. That's good. Learn about NC is good. Wow, because Dr. Anas are the lecturers, I think the I'm not sure the end, because Dr. Anas are the lecturers. Okay, maybe. I'm not sure who that is, but thank you. But hopefully you will not regret your decision midway of this course. Future, okay, future use. Try to be influence. Destiny choice. Oh, ini orang yang ni yang bagus ni. Other electives are full, okay. This is jujur. Other electives are full. What else? About the oh, because of the lecturer, okay. Thank you. My favorite course. How can this is your favorite course when you haven't started yet? Okay. That's quite contradictory. Okay, so thank you for those who responded. Okay, I've got one more questions. Okay, we should stop this. Okay, just 1 second. Okay, so let's try. I'm sharing one more. Okay, all right. So got one more question. Again, go to Menti and enter the following codes for the next question. I think this is a very easy course because as someone said just now, he or she is taking this course because of the lecturers. Maybe he or she thinks that it's easy to get A with me, kan? Maybe. So my next question, okay, do you think that this is an easy course? Sure A lah. Okay? Just give me your honest opinion. Okay, so enter the following codes and we'll see the answer. Okay. Okay. So let's see the next response. Oops, that's one. It's good. Wait. I got no response from students. Boleh hilang eh? Got one, two. What happened to the rest? Yes. Well, someone said this should be an easy course, huh? Okay, let's wait a few more students. Okay. All right, so we got 15 respondents. So yeah, a quarter of the class. So okay, so let me help you to answer this very question. This is an easy course. Sure, A lah. Is it? Yes, if you attend all the lectures, if you watch all the videos that's given, if you put effort to read the textbook that's given, if you understand all the materials covered, meaning that from the first week until the last week, week 14, you follow everything, you understand everything, you shouldn't have any problem. Because by right, okay, this is some tips that I can share with you. Elective courses basically are meant to help students, basically. It shouldn't be that difficult. Not to say elective courses are easy, because it's a fourth year course. But elective courses usually helps students to get A, basically. If you follow all the assessments or all the materials covered from the first day of the semester. It is an easy course, yes. Okay, but again, provided that you understand everything, you ask questions and so on and so forth. No, because maybe you look at the derivation that I've shared just now, you are a bit nervous. Do not be nervous, because the derivation will be shown in details. Plus, it's something that you have covered before in fluid courses. So it's just a recap, and of course, we are going to look into a bit more details on the derivation. Okay. Maybe this is something that you are not sure. Maybe this is the students who have no other choices, or the other electives are full, so you are not sure. Okay, but for me, the life gives you lemon, so you make a lemonade. If you attend all the sessions, put efforts in everything, or assessment, not just the lab, all the assessment, you should be fine. Okay, so I think you know my style. I'll do my best during the lectures, during the delivery of the assessments, delivery of the teaching. So I hope I get some response, a good response from students as well. Okay, so I think that's all that I have for today. Yep. Okay. Yep. I think that's all. So now is close to 9:40. Can I maybe open for questions from students? You got any questions? Okay. Any questions? Felt is a good choice. Okay, 9:40. I'm not sure what I mean meant. I think I missed. Okay, Fidos as well. Okay. Any questions from anyone? You can just type your question in the box, chat box, or you can ask directly. Please. Question from students? Okay, no questions. Everyone is tired. Just Dr. Anas yang mengajar. Yes, Firdaus. Unfortunately, I'm the only one teaching this course. I hope that's fine with you. Close to 10. What's that supposed to mean, I mean? Okay. Anything else about the course or anything? Anything else, Tada? Okay. So if you got as you planned before 10, yes. Okay. All right. So I think let's end this session if you got no more questions. Thank you everyone for those who attended. I really appreciate it because out of 62 students who registered for this course, we have 47 who attended tonight's session. And it shows something. For me, it shows something. It shows that you want to learn, you want to know something about this course. And I really appreciate it. And I hope to see you all in the next class on next Monday, physically, at I think BKN 6 and 7, if I'm not mistaken. So I'll see you next week, inshallah. So before we meet, make sure to go through the materials that I posted on Google Classroom. And more importantly, if you want to know more about the lab, just go to the videos on my YouTube channel. Okay, so with that, thank you so much, everyone. I hope we'll have a good semester, and I look forward to see you all next week, inshallah. Assalamu alaikum and very good evening.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.